joining today's OML Office Hours session. I'm Sherry LaMonica with Oracle Machine Learning Product Management, and I'm joined by Akash Dharamshi, a solutions engineer with Oracle Analytics. And today we'll be covering the Oracle Machine Learning for R, or OML4R REST API for embedded R execution. Please enter any questions you have in the Q&A, and we'll address them at the end of the session. Here's the agenda for today's session. First, we'll provide a quick overview of OML4R embedded R execution and the benefits and motivation for using it. Then we'll show you the different interfaces for embedded R execution, including the REST API. But we'll do a deeper dive into the REST API, show a typical workflow, a short demo, and then open the floor for Q&A. If you're looking for a more comprehensive embedded R execution presentation, Akash did a session a few weeks ago that you can look up in the Ask Tom. Let's start with the introduction. Embedded R execution refers to running R functions which may contain third-party code in the database environment. And specifically, it's the ability to run these R functions in R engines under the control of the database environment. And those R engines can be spawned in a data or a task parallel manner. The functions can be invoked from the R interface, but also using the SQL interface or REST endpoints on Autonomous Database and using a SQL interface with Oracle Database. Embedded R execution works with the OML4R data store, which is a repository in the database where R object can be saved and then passed to user-defined functions. And also with the script repository, a database table that stores the user-defined functions and can be invoked from embedded R execution. And you can retrieve structured or image results depending on your application's requirements, for example, a table, XML, PNG, or JSON. So why use embedded R execution? It enhances OML4R functionality by enabling users to run third-party packages inside of R scripts in the database environment and can potentially improve performance when run in parallel. It facilitates the use of R scripts in applications where you develop your R scripts interactively inside the R interface and then invoke them from application-based SQL or REST interfaces. The R scripts are stored securely in the database and can be scheduled to run automatically through SQL using the DBMS scheduler. And all of these features facilitate and streamline the collaboration among data science teams. So it allows the handoff of your work products from data scientists to application developers for deployment. So with embedded R execution, users can score data at scale when using third-party packages such as GLM to build a model and then score chunks of data in parallel. Users can also automate building multiple models aggregated by a grouping variable in parallel, like grouping by the data by color or gender. And you can build a model on those data partitions and save the results in the database or access the results dynamically in applications or dashboards. And we can also conduct simulations by invoking a function multiple times in parallel. So let's take a look at the interfaces for embedded R execution. So you'll use the R interface to develop your functions and create reproducible, shareable scripts. And the SQL and REST interfaces are used to deploy these scripts in applications. So you can develop and share your own R functions, including third-party code with R, and then leverage the parallelism and scalability of the database through embedded R execution in R or SQL. And then, depending on your application requirements, deploy those same functions using SQL or REST. With the SQL API, scripts can be scheduled using the DBMS scheduler. And the REST API allows you to deploy scripts in REST applications through HTTP. And it has no client package requirements other than a REST client like curl or Postman to initiate the calls. A couple of things to be aware of. The REST API for embedded R is available on Autonomous Database only. And right now we have a small subset of third-party packages that we include with OML4R and Autonomous Database, but third-party package installation, by the user will be available in Autonomous Database later this year. So let's take a look at the specific functions used for embedded R execution. So in this table, we have the R SQL and REST equivalents for embedded R execution. Do eval and RQ eval invoke a standalone script, no table input. Table apply and RQ table eval invoke a script with table input. Row apply and RQ row eval invoke the script on chunks of rows in parallel. Group apply and RQ group eval invoke a script on a grouping column, and then index apply and RQ index eval will run a script a specified number of times. So the user specifies the number. And again, the functions in the last three rows, the row, group, and index-wise operations, those are all parallel enabled. Okay, now let's take a closer look at the REST API. Here's the basic architecture for the OML4R REST services. You'll use a REST client, curl or postman, to get an authorization token. And with that authorization token, you can have access to all of the OML4R REST endpoints. To get the token, you need to have an autonomous database username and password. And the user needs to be granted OML developer role by your autonomous database administrator. And I say this because sometimes there are users that may not necessarily have grants for Oracle machine learning specifically. You might have the grants for connecting to the autonomous database and running certain queries, but not for the OML capabilities. So once you have the OML developer role and the token, this allows you to have access to all of the REST services that are residing in your data center region. In order to get that token and to get access to the REST endpoints, you need the URLs, the OML URLs that correspond to your tenancy and database. And you can get these from database actions under related services. There are two URLs that you need there. One is for OML services, which is a different OML product. But for OML4R, there's one URL that's used to get the token, and then another URL that you will use to list and run the scripts that you've saved in the script repository. So you'll copy those and keep them handy. And this is the structure of the OML REST URL for all of the REST endpoints. So it has your tenancy ID embedded there, the database name, your data center region, along with the root domain, which is oraclecloudapps.com. So for each database, the tenancy ID and database and potentially the region will be different, but the root domain is the same for all of the OML REST URLs. And these are all of the OML4R REST endpoints and their methods. The administration components are for getting the authorization token. The generic components are there so that you can view the open API specification. And then we can list and invoke the scripts that you have available to you, which will be either the scripts that you've created and saved, or scripts that another database user has saved and shared with you. And again, group apply, row apply, and index apply, those are parallel enabled. Scripts can be run in synchronous mode, which is the default, but we also have asynchronous mode for any scripts that take longer than 60 seconds to complete. And when you're using asynchronous mode, there is the ability to poll the job status to see if it's still running, and then look up the job result according to the job ID that's provided. You can also provide a timeout on the job as well. There's a timeout parameter. Okay, so before we get into the demo, I am going to go through a typical workflow and best practice when using the OML4R REST API so that you can get a general idea on how this works. So this is the workflow. You'll start by just writing your R code and making sure that it works in R. And on Autonomous Database, this will be in OML notebooks. And then create a function from the code. That's that second step there. And a best practice at this point is to be sure that the function works as you expect. So you want to run it in R and make sure that the function works in R, just using like a standard data frame. And then run it in embedded R execution to make sure that everything works there as well, that you're loading the data correctly. And if you've saved something to the data store, like a model that you want to use for scoring, and just make sure everything works at this step, fix any issues before you move on. At this point, you will save the script to the script repository and run the function that's saved in the script repository, and you'll run it as a named script in that case. And once you know that that's working okay, you can get a token and then just run the function from the REST API. So what does this look like in practice? So in this case, we're defining a function in R with the name build GLM mod. Building a GLM model saves the model to the data store, and the function takes the data and the data store as input. Then we use the ORE script create function to save the function to the script repository. ORE.sync is used to get the proxy object iris, and then we invoke the function using ORE table apply. We're, in this case, specifying the script and data store names. So here we've just built a model, saved the model to the data store, defined a function, saved it to the script repository, made sure everything worked as we expect, and then run it for the R interface for embedded R execution. So next we're going to define a scoring function that loads the model from the data store, and then we'll save that and run it from the REST API. So we can store scripts in the script repository from either the R or SQL interfaces. And in this case, we're creating the scoring function, score GLM mod. It loads the model from the data store and does the scoring. And the script in this case is created as a private script, so it's not shared with the other users in the database. And we overwrite any script with the same name if it exists. When we save the script from the R interface, we're using ORE script create, and from SQL, sys.rq script create. And I'll show you an example of this in a little bit. Okay, so now let's get the token and run the function from the REST API. So this is the token request using curl. And the items highlighted in green are provided by the user. So that's the OML user and password and the OML URL that corresponds to your database. And then you can see the token portion of the URL. That's that OAuth2 v1 token, which is the same for every database. And once this call is initiated, the token is returned. And that token is valid for 1 hour, but it can be extended before it expires or refreshed. Or you can get a completely new token as well. If you'd like, you can list the scripts that are available to you, which will be the scripts you've saved and in the script repository, and then any scripts that were shared with you by another user. And to do this, you'll send a GET request to the scripts endpoint, and you'll need to include your token with the request. If you want to get the open API description, you'll send a GET request to the R scripts version 1 endpoint. And again, you'll include your token along with the request. This will return all of the available endpoints along with their API descriptions. And of course, you can also see this in the REST documentation for embedded R execution. And then finally, you're going to run the scoring function, score GLM mod from the REST API. So we're sending a post request to the row apply endpoint, specifying the input table iris that we want to score the data in parallel chunks of 50 rows using the medium service level, which is corresponding to the level of parallelism that we want. And again, we have to include our token in the request. So about that medium service level, Autonomous Database offers parallelism through these different service levels, and the service levels are low, medium, and high, and they control the degree of parallelism for the jobs. Low has a maximum of 2 degrees of parallelism, medium has a maximum of 4, and high has a maximum of 8 degrees of parallelism. So specifying parallel flag equals true and the service level enables parallelism for your REST jobs as well. Okay, let's move on to the demo. I'm going to bring up my notebook environment now. So this notebook is basically just going through the same workflow that I showed in the slides. It assumes that you're using curl for all of your REST calls, but again, I would encourage you to look at Postman. It's a nice IDE. There are other IDEs for REST that you can use, but I really like Postman. Anyway, so the first thing that we're going to do is to get that token. And you can't run this actually in in OML notebooks, which is what we're looking at right now. We're looking at OML notebooks. This is a markdown paragraph. I'm just showing you the curl that I would run in my Mac or Linux terminal. And what I have done here is I have exported my OML server URL to a variable. And the same, I did the same with my username and password so that I can easily pass them into the curl request. This token that comes back, as you can see, I've shortened it here. It's very, very long. And it's much easier to also export your token to a variable and include it as a variable in subsequent requests. So I'll show you what that looks like. So we're sending our post request with our username and password to the token endpoint. And then the token comes back inside these quotes here, and it tells you that it's going to expire in 1 hour. That's the 3,600 minutes. And then you can take that token and export it to a variable in your session like this. So I have my token. I just started out with that. So now what I'm going to do in this R interpreter here in Autonomous Database, I'm going to, I can work in R and run R commands here. So I'm going to create a proxy object called iris using the built-in data frame iris, and then show the first few rows. Then create this R function, build GLM mod, and then save it to the script repository. And if you haven't worked in OML notebooks, you can get a status of how long it took and who last ran it and when. So I ran this last night. And you can see that it's been saved, and then I'm overriding any script that may exist in the script repository with the same name if it exists, just to make sure I have the right function. And then I can view the script in the script repository using ORE script list. I'm specifying type equals user here. And what that means is I just want to see the scripts that I've saved. I don't want to see the scripts that are shared with me, just the ones that I've saved. And so there we have the build GLM mod. And then I just run the script in R, like, does my code have any problems? We set it to return true. And I would try to troubleshoot any problems that I had in my script at this point, because once you are, maybe using SQL or REST, it's much more difficult to troubleshoot. This is your sandbox environment. Then I run the script in the embedded R execution R interface using ORE table apply. I am calling the function from the script repository. So I supply the function name, build GLM mod, and then I specify a data store name where I want to save the model, in this case, DS2. And then I can view those two data stores that I just created using ORE data store. It tells me the name of the data store, how many objects are in there, and the size, and when it was created. You can provide a description if you like when you save objects to the data store as well. I did not. Or ORE data store summary gives you a different view or look into the data store. Here we're looking at the summary of data store 1, DS1, gives you the object name and the class, size, length, and other information as well. Again, in the R interpreter, I am defining my scoring function. And the scoring function takes the data and data store name. It loads the model from the data store that I'd previously saved, and then it will do the scoring with predict. Now, to save the function to the script repository in R, I have two options. If I want to keep working in the R environment, I use the R interpreter with ORE script create. I'm specifying the name as score GLM mod, and the function that I've defined is score GLM mod, and I'm overriding any function that already exists in the data store. From the SQL API, I'm using this script interpreter, which is PL SQL, because I'm using a PL SQL block to do that with sys.rq script create. So these are equivalent, and just depending on the environment that fits your application requirements, you might do that from R or from SQL. Both are possible. And then I run the scoring function from the REST API against the row apply endpoint. So let's take a look at this. This OML server, that's my OML URL. And this is the row apply endpoint right here. Score GLM mod is the name of my script. The input table is Iris. And the parameters here that you see is a JSON key value pairs. Those are the parameters to my function. So I'm supplying the data store name there. I'm doing data store 1 again, but you can supply any data store name that you want. And I want to score the data 50 rows at a time in parallel. So parallel flag is set to true using the medium service level. And when I do that, of course, again, this would be in like a Linux terminal. The return value comes back as this. This is a portion of the return value. And that's all I have for the demo. Then we will point you to more information under the down here under the OML4R documentation under OML4R 2.0. We have the REST API for embedded R execution documentation is there. But here's our OML webpage and our blog, our GitHub repository that has lots of samples, the OML office hours, and the OML4R documentation, as I mentioned.
There are a few questions that just came in. So let's start with the first one is, are there any differences in scalability between the three modes? So maybe the low, medium, and high service level.
Yes, because the low service level only allows 2 degrees of parallelism, while medium has 4 and high has 8. So if you need the greatest amount of parallelism would be with the high service level. And of course, you would need to just, play around with that to see what works best for your function.
Okay, and then another question is, are predictions accompanied with the confidence level?
It just depends on what function that you're using. I was using GLM, but that was just an example of an open source a function that you could use, an open source model. So that would depend on the third party package that you're using.
Great. And then another question is, where can this notebook be found?
I will post this notebook in the Ask Tom after the session when we post the recording. But there's also, you should also look here, because one thing I didn't go over is asynchronous mode. So I'm going to go back to my autonomous database here. And if you're not aware, you can go over here to the templates and then examples. And then we have, I think the last time I counted, I think there were like 117 sample notebooks in here. And you can go ahead. So if you can search on REST, you can, this OML4R REST API, if you click on this and do create notebook, this is a good place to get started. Then maybe move on to my example. But this is available in your autonomous database today. So go ahead and go through this as well. Okay, I see more questions. Is REST API execution less scalable in any way given its HTTP route? I don't think so, but maybe we could talk about that one offline to see what the use case is. Yes, Fancy. Fancy's asking, are there any similar functionality in Python? The OML4Pi REST API is also available and has similar endpoints for running scripts in embedded Python execution. Fancy, I will send you the link to that documentation after the session. Is there any way to get the logs when I'm running OML4R embedded R execution through REST? And you can enable logging through curl, and you would do that through Postman as well. Do the R packages include XGBoost and SVM? Nope, but we are very, very close. Our packages included in Autonomous Database today do not include XGBoost and SVM, but we are very close to releasing third-party package installation by the user. Can Oracle Analytics Server use these APIs? I guess we can talk more about that offline. Any of these APIs can be accessed through any REST interface. So if you have a REST client that you can use, you will be able to access these APIs. There's another question for the REST API. Is the precondition that the data should be Oracle Database, Autonomous Database? Can the data be in the object store? So again, the REST API for embedded R execution is only available in Autonomous Database, and the data will need to reside in the database. Now, your function could, if you had like a CSV file or a text file in object store, and you wanted to grab that and create a table out of it using the DBMS cloud packages in your OML notebook, you can do that. We do have an example doing that in the template notebook. So if you want me to point you to that, send me a message offline. Good questions. Okay, thank you very much for joining, and we'll see you next week.